Hi everyone, this is Mohit Bansal and we are going to talk about blockchain and its applications. So we'll be starting with very basics of blockchain. Even though you don't understand anything tech, you should be able to understand what blockchain actually is. So before getting into blockchain, let's see this demo from Anders. So this particular website which I'm just opening is, you can say, a gold standard for understanding blockchain, which each and every course kind of uses. And this is actually developed by Anders. So you can see that a blockchain is nothing but a connection of blocks. So we'll see what that actually means. But we can see that this block one and block two, they are linked with a key, which is hash in the previous hash in the second block, and so on and so forth. So actually what happens, let's say I go and try to change something in block 2, the entire blockchain gets invalidated. So we'll see what this mean and what are the reasons behind it. But in a nutshell, a blockchain is nothing but just a time-stamped append only ledger, which means that each and every block has a timestamp attached to it, and it works in a way that you can only append entries to it. You cannot really go back and change the entries. Again, we'll go into depth, but let's see one more interesting website, which is from blockchain.com. Here you can actually see what is going on in most of the blockchains. So we'll be focusing mostly on the Bitcoin. This website gives you a high level view of what is actually happening in Bitcoin world. So you can see the information like what is the price, how many transactions were done in last 24 hours, how many Bitcoins were circulated, and what is the transaction volume. You can see the blocks and the transaction as well. So let me go to the block within the Bitcoin network and try to show you what actually the block mean. So you can see different informations, but the most important information is time, and there are transactions associated within each block. So the way it works is you have many transactions which you want to put on blockchain. So what miners typically do, they go and fetch few of those transactions, try to create a block out of it. So these are some of the transactions. For example, this guy transferred 0.0024 BTC to this particular guy, and you might be wondering where the remaining 0.0006 Bitcoin goes. It goes toward the fee. So all of these terms we'll try to understand, but for now, just understand that blockchain is nothing but just a timestamp up and only ledger. Moving forward, so there are few of the applications which you might have come across. For example, Bitcoin, everybody knows, so it needs no introduction. There's this idea from Bolts where they are trying to bring voting systems on blockchain. Since trust is the main component of blockchain, so votes is a good contender. Similarly, Rust IQ, they are working on bringing health data over the blockchain. Again, since health data, hence it's sensitive, and it needs a trust, hence blockchain. So many times you will get these terms interchangeably used by many people, blockchain and databases. So just understand that blockchain can be referred as a database, but vice versa is not true. So, so before getting into further depth, let's first try to understand what are the different databases and what do we actually mean. So the first kind of databases is centralized. As the name suggests, there is a central server or central DB where different computers, different nodes, they can fetch the data. This is vulnerable to data security issues because a single point contains the responsibility of serving. So if this node or this server fails, then nobody can fetch the data. So the entire system goes down. At the same time, the people or many of the nodes are trying to fetch data from this DB, then response time will go down. Towards positive points, it's low cost to set up and easy to set up, low maintenance. So for example, let's say if I want to relate to the real world, let's say Ram started his startup in the space of blockchain, but since he didn't have money, so he managed entire thing starting from HR to IT to finance and customer relationship. So now if you see if Ram fell sick or Ram goes out of office, then nothing will work. It's so the same thing with centralized system. If the server goes down, then nobody can work. Right. Moving forward, the next type of database is decentralized. So instead of storing all the information in a single server, what you try to do is you try to divide information in parts and store them on different servers. So for example, let's say this particular server is for ID data, this server is for employee data, this is for customer data, and so on and so forth. So each of the nodes can connect to any of those. Now you can see that we have limitized our points of failures, and because we are connecting to multiple servers, we will see higher throughput rate or higher response rate. But at the same point in time, there is a downside that you'll have to manage all these servers. So the maintenance costs go up. Coming to Ram, let's say he learned from his mistake and now he has set up different departments for IT, finance, HR, so on and so forth. So now, even if let's say IT head goes for a leave, then company can still work. So that's the idea of decentralized. The next type of database is distributed. So basically, instead of storing the entire information on single server, whether it's just related to IT or not, what you do is you try to store data fully or partially on many of the servers. Basically, this server will store some part of information. Let's say we just talk about the IT data. So some of the IT data will be here, some of the IT data will be here, some of the data will be here, and there can be overlap between these. So what we have actually done is we have kind of most probably removed the dependency on a single server. Even if one of the node goes down, there is no loss of information. Even if there is, we can retrieve back from other servers. So you know the design, how it is designed. For example, Hadoop. Right? So there are different nodes and information is stored. Even if one of the nodes goes down, you won't really see a difference. Right? So again, coming to the nodes or the users, they can connect to any of these servers. Next, we'll see what are the different components of Bitcoin network and how can we achieve a Bitcoin network using those.